Welcome to our first application of the factor theorem. In our example, we have a rectangular piece of cardboard measuring 12 centimeters by 8 centimeters made into an open-topped box. So the length is 12, the width is 8, and we have an open-topped box by cutting squares from the corners and turning up the sides. So what does it mean that we cut squares? Squares have equal sides of x and x. So let's see what that picture would look like. From our rectangular base, we cut corners of x sides, so x and x. So now let's think about what will the new length of the cardboard box will be. If the original length was 12 and we are removing x from each side, what will the new length of the box be? And really the same question applies to the width of the box. If it was 8 and we remove x from each side, what will the width be? Well, the length will be 12 minus 2x, because we're removing 2x from the original length. And the width of the box will be the original 8 centimeters minus 2 times x, which belongs to the squares that we removed from the corners. Well, right now, let's think about what the problem is telling us. The volume of the box is 60 centimeters cubed. Well, what is the formula for volume? It's length times width times height. In this case, the height is that folded piece of cardboard, which is x centimeters long. The length is 12 minus 2x, and the width is 8 minus 2x. And we are told the volume is 60 centimeters cubed. Well, what we have to do right now is put it all together. Think of it as an assembly line that you have to put together in order to complete the finished product. So we're going to multiply the length times the width times the height, and we're going to set it to equal 60. What I want you to do right now is to expand the product on the left-hand side, and we're going to try to use our skills, factor theorem, remainder theorem, polynomial factoring, solving equations to solve these particular equations in terms of x. First, I'm going to expand the first two brackets, 12 minus 2x times 8 minus 2x, and then we're going to multiply by the remaining x and rearrange in the order of the powers. So 4x cubed minus 40x squared plus 96x minus 60 equals 0. What we notice is that every coefficient is a multiple of 4, so we're going to divide the entire equation by 4, and we're left with x cubed minus 10x squared plus 24x minus 15 equal 0. So what do we do right now? Well, we have a cubic polynomial that we're trying to factor, and we're going to use the factor theorem in order to find factors of this particular polynomial. Well, the constant is 15 or negative 15. What are some factors of 15? Positive and negative 1, positive and negative 3, positive and negative 5, and positive and negative 15. The polynomial at 1 equals 1 minus 10 plus 24 minus 15. Well, what do you notice? The polynomial at 1 equals 0. That means that x minus 1 is a factor of the above polynomial. And once we have a factor, what did we learn in our classes to do? Right away is to perform the long division between your cubic polynomial and the factor you found above. So we're going to divide x cubed minus 10x plus 24x by x minus 1. Now, I want you to take a couple of minutes and perform the division on your own. However, in the interest of time, I am going to produce the results in a second. And I'm hoping you're going to reach the same conclusion, that the quotient of that division is x squared minus 9x plus 15. So how can we rewrite the polynomial? As a product between x minus 1 and x squared minus 9x plus 15. And we know that this product equals 0. When is this product 0? When either the first bracket is 0 or x equals 1, or the second bracket, x squared minus 9x plus 15 equals 0. So we already have our first option for x equal 1. However, we do have to explore the second option. We do notice that it's 9 and 15 do not factor easily. So we're going to use the quadratic formula and calculate the discriminant first. B squared minus 4ac. It's 81 minus 60, or 21. Which means that we have two possible x values. X would be 9 plus or minus square root of 21 is 4.6 divided by 2. Well, if we choose the positive option, 9 plus 4.6 divided by 2 is 6.8. Or the negative option, 9 minus 4.6 would be 4.4 divided by 2, or 2.2. So what do we notice right now? We have three possibilities for x. X equals 1, x equals 6.8, and x equals 2.2. We do have to explore all three of them because these are three possible sets of dimensions. And we have to see if we can generate possible length and width for that cardboard box. Well, if x equals 1, we know that the length is 12 minus 2x, or 12 minus 2, which equals 10. The width is 8 minus 2x, which equals 6. And the height is x, which equals 1. So that's our first case, so the scenario works. If x equals 6.8, we repeat the process from above, and we substitute x in the formula for length and width. So the length would be 12 minus twice 6.8. However, we notice that we would get a negative number, a negative result, which means that for x being 6.8, there is no such box, so we cannot consider this case. And if x equals 2.2, the length would be 12 minus 2 times 2.2. Again, you have to substitute the value of x into 12 minus 2x, which means that the length is 7.6. And for the width, we repeat the process, 8 minus 4.4, or 3.6 centimeters. And of course, the height, which is equal to x, equals 2.2.